So we want to write this in standard form. What would we have to create first before we could get into standard form? What could I write if I do know my zeros?
Your factors.
Yes, so if I know zeros, so a common theme you're going to see throughout today is if you know your zeros or your roots or your solutions, write your factors to help you then write your equation. So let's start off with looking at our zeros, writing those factors. So if I know x equals 0, what would that factor have been? Just x. Awesome. What about if I know my zeros at 2?
X minus 2.
Good, x minus 2. Now I have 3 over 2. What would that factor look like?
2x minus 3.
Yeah, so let's do this maybe in 2 steps. X minus 3 over 2. I typically kind of keep my factors like that.
2x minus 3.
Good job, Morgan. How'd you know that is equal to 2x minus 3?
Because if you set it to 0, it gets you 3 halves.
Yeah, kind of. If you would have set that equal to 0, you would have moved 3 divided by 2. If you can get this far, just know that if you multiplied both these terms by 2, that would get you rid of that fraction and into in front of your x. So are we in standard form? No, what would we have to do to get there?
D factor.
What is D factoring?
Distributive.
Yeah, distribute, and then we'll FOIL. So let's distribute this x just into the first term, right? I don't need to multiply it into both. That's multiplying it twice. So just x squared minus 2x. I heard someone say distribute, and then I heard someone say FOIL, and that's what we're doing next. So go ahead and FOIL through to kind of finish that problem out. Keep waking up your brains, getting back in the swing of things. So I'll work on it up here, but you try and finish it out on your own.
That makes sense. Oh, no, we don't factor, we just D factor. I don't know. What's this?
Alright, so I have 2x cubed minus 3x squared minus 4x squared plus 6x. Am I in standard form?
No, you gotta
What does that mean?
put them together.
Put them together, combine like terms. So we will end up with our polynomial being 2x cubed minus 7x squared plus 6x. After we distribute, FOIL, combine like terms.
That's it?
That's it. Right? So we are going to get harder. We start off.
That's so
So if you got here, what questions do you have before we build off and do get a little bit more challenging? So I have a big idea that we're starting off for today. We are given zeros, write the factors, multiply through to get your equation. Alright, so here's how we are going to get harder. Because that was just when we were given some nice roots that are all some nice numbers, like 0, 2. We even made that number 3 over 2 to kind of be a pretty nice factor. Those were all those nice rational roots. But I know I can have roots beyond those nice rational roots. I can have imaginary roots. Oh, I know. So if you know you have an imaginary root, you also know its conjugate pair will also be a solution as well. Right? Because those imaginary solutions come in conjugate pairs from your plus or minus with your quadratic formula. So if I want to write a polynomial in standard form with a leading coefficient of 2, and roots at x equals 3 and x equals 1 minus 2i. From that problem, what are some things we know? What are some things we know that can maybe help us get to that equation?
Has a leading coefficient of 2.
Leading coefficient of 2. That's a good thing we know. What else do we know?
One of the factors is going to be x minus 3.
Awesome. So if I have a root at x equals 3, I know one of my factors is going to be x minus 3. And I know that leading coefficient of 2 means I got a 2 out here. That's kind of like that k value we typically have. So we also know one of our roots is 1 minus 2i. If I know one of my roots is 1 minus 2i, what else do I know? That's one imaginary solution, but it has to come in pairs. So what's the pair that goes with 1 minus 2i?
1 plus 2.
1 plus 2i, that is its conjugate. 1 plus 2i. So here's where we are going to build off and make things harder. I need to write my factors for this. And how do I write factors? Think about when I had 3, right? It's your x minus your 0, right? Because that's why if I have a negative, it turns into plus, 2 minus a negative. So I have x minus my 0, which here my root is 1 minus 2i. So I would recommend putting parentheses around because you are going to have to distribute in because there's 2 terms. Now, I also know my other factor would be x minus 1 plus 2i. So let's just distribute that negative through because that kind of help us see what that factor will be a little bit more. So I would have x minus 1 plus 2i. And I would also have x minus 1 minus 2i. And those are how we're getting a little harder, right? These are my other factors that I have. So once I give my zeros, I write my factors. So I have x minus 1 plus 2i. And I had x minus 1 minus 2i. And now what do I have to do? What do you think, Morgan?
Well, I was just going to ask, why don't they write the 1 plus 2i also?
Because that would make the problem much easier, wouldn't it?
Okay.
So I'm going to say this is kind of like a probably big test level question, right? Because it's testing ideas of like if you are given if you're given one imaginary, can you find its conjugate pair? Can you write the factors? Can you multiply through, right? And get your equation. So that is what we're going to do next. We're going to multiply through. And this looks pretty daunting to multiply through. So I have a very big helpful hint. My very big helpful hint is always multiply your factors with your imaginary roots first. Because these are conjugate pairs, you'll see why. Because a lot of our imaginary terms, when we're multiplying with a conjugate pair, are going to become 0. So let's multiply these together to see what happens. So remember when you're multiplying, kind of take each term to distribute in. So we have x squared minus x minus 2ix. Then we'll take minus 1, multiply it in. So we'd have minus x plus 1 plus 2i. And then we'll take 2i, multiply it in to be a plus 2ix minus 2i. And here's the kicker for our last term. We have positive 2i times a negative 2i. Let's think back to our work with imaginary values. I'm going to have 2 times negative 2. That'll give us negative 4. But I also have I times I, which would become I squared. So what is negative 4I squared? Positive 4. That's it. We gotta remember that. I squared is negative 1. And then we'll be all set. Good to go. I'm just going to bring this part in red down. So that looks a little scary, but it's not as scary as it seems. So let's start combining like terms to see why it's not going to be so scary. So, combining like terms, nothing else combines with x squared. What are some other like terms you guys see?
Negative 2x.
Oh, yes. I have negative x and a negative x. That'll give us negative 2x. What else do you guys see?
You can cancel out the 2ix.
Yes. I have a minus 2ix and a plus 2ix. That becomes 0.
Same with the 2i.
Great job. I have a positive 2i and a minus 2i. That becomes 0. See? Not so scary because all my imaginary terms, boom, combined to become 0. And my last term is just going to become what value? 3. See, not so scary. So let's just multiply that 2 into this x minus 3. And now I'm going to just finish out to become in standard form, right? Not in standard form. I'm still actually in factored form. So to become in standard form, what do I need to think about doing next? Great job. Just distribute through. So why don't you guys take a minute, multiply through, combine your like terms, see what you find, and then check in with whatever we get on the board. Okay, so multiplying through, you get 2x cubed minus 4x squared plus 10x minus 4x squared plus 12x minus 30. What's else? What is our final solution after you combine your like terms? What'd you get, Mithra?
3x cubed minus 10x squared plus 22x minus 30.
Awesome. So, like I said, this could be like a test level question. So what are some things that you were given from your problem that you can use to check to make sure you got this right on the day of like your test? What's something about your problem that you should be like, okay, this is a good check. Like, I got this right. What do you see, Alex?
The coefficient is leading coefficient is 2.
Yes, love that. I was given my leading coefficient of 2. Do I have a leading coefficient of 2? Yep, that's a good check. What else could I do? What else do you think, Morgan?
You have to have 3 roots,
Yes.
and like the biggest degree is 3.
Good, that's another good check. This is why math is so nice, right? Like, I could be working on stuff and be like, feel pretty good. Like, yeah, I got this question right. How can I know, like, another way for sure, like, yeah, I got this question right? Those are just, like, good things to, like, observe and notice that you're, like, on the right track. How do I know for sure that this one was right, though?
Factor again.
Oh, do I really want to do that to myself? No.
So
But what else could you do if you don't want to factor again? That we've done before. Yes, Liam, if I put my root in. So what root looks easy to plug in that I was given? 3. If I plug in 3, what should the output be?
0.
Yes, good job, guys. That's how you would know if you got it right. What other questions do you guys have? Alright, we're gonna now, we were writing equations, just kind of like given situation. Now we're gonna write equations given graphs. So why don't you guys take a moment, look at this graph here. I want us to take a minute on your own. Jot down all the things you're noticing about this graph. Alright guys, so let's check in and see what we were noticing. So let's start with you guys and Vivian, you guys at your table. What is something you noticed here? Ooh, we know our real roots. What are those? Nice thing. What are those real roots we had here? Great job. You know that those are real. That's where we cross the x-axis. So we have x equals -3, x equals 2, and x equals 4. Okay, cool. That's a good start. What about you guys in our front middle table? What else did you kind of notice about our graph?
That's 2 turning points.
We have 2 turning points. If I have 2 turning points and I cross my x-axis at 3 times, what's something I know if I'm trying to write this equation that I should have? Yeah, my highest degree is 3, so I should have a degree of 3. Okay, cool. What else do you guys know that we should have? What else do you see, Sabina?
The leading coefficient is positive
My leading coefficient is positive. How do you see that?
because it's like going up towards positive.
Yeah, we have down and up for my end behavior, so I know it'll be positive coefficient, and it's odd. Anybody have any other ideas? No, Morgan.
2 turning points.
Yes, we got that. So we know our degree is 3. What else do we have? So let's say we want to take this and write our equation. What could I do next to write my equation?
Right, factor.
Yes, good. So this is your steps to write your equations. If you want to start off by just jotting down things you notice, right? Like your end behavior, your degree is 3, you have 2 turning points. You want to write your zeros and their multiplicity. So we got x equals -3, 2, and 4. That was Vivian told us from the beginning. Now Evan's telling us what can we do from there. We can write the factors. And then we're going to have that a value that we're going to have to figure out. So Sabina was already telling us, okay, we know that a value should be positive. Like, do I know what that number is? No. So let's find that value, but before we do that, we're going to write the factors. So if I had x equals -3, what would the factor be? If it's x minus 3, or sorry, x equals -3, what would that factor be?
X was 3.
Good, x plus 3. What's my next factor if my solution was at 2?
X minus
Great. Now, if I have my solution at 4, what's my next factor?
2.
Great. And there's some value for a that I don't know. That I'm going to have to figure out, right? There's a stretch, compress, something. I don't know what that is, right? We've been here before, something we've done before with our quadratics, right? With quadratics, we maybe just had 2, but now we have 3. But it's still the same process. So how can we find that a value? What did we do before with our quadratics, kind of any other function to find that a value?
Plug in points.
Plug in points. What would be a good point to plug in? The y-intercept. And our y-intercept is 0, 6. So this is a really good point to plug in. I'm going to use 6 for y. And we will plug in 0 for x. So this will become 3. This will become -2. And this will become -4. So multiplying all those together, we would end up with 24 times a, which I know is just 24a. So therefore, what is our A value equivalent to?
4.
Almost. 1/4. Did this question say write in standard form? No, it just said write an equation. So if it just says write an equation, who's taking the shortcut with me and keeping it in factored form? But if it did say write it in standard form, what would you then have to do next?
Distribute.
Yeah, just distribute, multiply through. So since it does not say that, we're gonna just keep it in factored form because that's a little easier, right? And that is our equation. And you can kind of just do visually good checks, right? So some visual good checks would be, okay, I have a solution at -3, solution at 2, a solution at 4. If I plugged back in 0, if I plug in 0 into this, what do I know the output needs to be? If I plug in 0, what's the output? 6, good. So keep that in mind. And what other questions do you guys have here? All right, let's keep building and look at our next graph. So we want to write the equation here. Why don't you guys take a moment and, like we did with the last one, take a minute, jot down all the things you're noticing about this graph. All right, so let's start thinking, looking here. What about you guys, the back table near the flag? What is something you noticed about this graph? What'd you see, Laura?
Oh, the leading coefficient is negative.
Yeah, how'd you know that? Yeah, good. So kind of think about if you were connecting those, that'd give you like a negative slope. So you know that's in behavior went like up, down. So your leading coefficient is that A value. So you know A has to be a negative number. So that will be like a good check for when we solve for A at the end. What about anybody else have something else you notice? What do you see, Morgan?
5 real solutions.
Yes, so you have 5 real solutions, which means our degree is probably what?
5.
5, right? And that checks out because how many turning points do we have?
4.
4. So I know my degree should be 5. And what else would be helpful to know to help me keep going to write my equation? Kind of build off that idea Morgan was just telling us about. We have 5 real solutions. What are those solutions? Because where I want to go next is write those zeros. So what are those zeros we have? Yeah, so let's start. We have x equals -2. We have x equals 3. And what else do we have? X equals 0. So Morgan, you said we have a degree of 5. We have 5 real solutions, but we just wrote down 3. So what else is happening? There's 2 bounces. So at -2, what do we have? A bounce, which means there's what happening? Good. So we had a multiplicity of 2 at -2. And what about at 3? What else is going on there? Good. And notice at 0 we just passed right through. So there's just that multiplicity of 1, kind of nothing extra. So if I have my zeros and their multiplicity, where do I want to go next to help me write my equation?
Square the ones with the multiplicity.
Kind of think about what we did before. Think about if I just, let's pause on the multiplicity for a second. If I just know x equals -2, what would I want to write next? Yes, that's the factor. Good job, Sabina. So I would do x plus 2. Now, if I have a multiplicity of 2, that means I had this factor of x plus 2 twice. How else could I represent that? If I had x plus 2 twice. Good, I could just say it's x plus 2 all squared. So, that is how I show and can tell that my factor has multiplicity. I have that exponent of 2 outside of it. So now if I have x equals 3, what's the factor for that? X equals 3, what's that factor?
X minus 3 squared.
Good job, Evan. How did you know it needed to be squared?
Bounce.
Yes, there's a bounce, so that's a multiplicity of 2. And what else do I know? X equals 0. What's the factor for that? Kind of. Just what? Just x. So I might put that out here out in front. Just because that looks a little nicer to me. Now, Laura told us from the beginning that we would have that negative leading coefficient. So let's add in that a value that we need to solve for. So I'm going to have y equals a, x all the way out front. Okie dokie, so what's left to do, everybody? Plug something in to solve for what value? Great. All right, so how can I solve for a? What should I be plugging in to solve for a?
0, 0.
All right, so let's think about if I plugged in 0. I'd have a times x, which would be 0. So a times 0 would just give us 0. So that's not helping me solve for a. Let's find something else. What else do you see, Alex?
Oh, wait, I was just gonna say, should there be a negative sign in front of the A?
Great question. We do know a should be negative. If you want to do that, what you're going to find in the end is you would find a positive value for a. For me, I'm going to just solve for a and know my a value should be negative in the end. So when I'm writing my equation at the end, like my a value should be negative. It doesn't matter either way. You would still get like the correct solution. I just know like as I'm solving, I'm going to find a negative a value. So like kind of give me a visual check.
Okay.
Good question. Where else were we going? Okay, we were trying to find a. And Alex was just reminding us, we know a should be negative. So how can we keep finding that a value? Something we've done before. Something we've done before. Evan gave us the idea of plugging in 0, 0. That wasn't going to work. What else could we do?
X-intercept.
Yeah, so none of my x-intercepts are going to work because if I plugged in -2, -2 plus 2 is going to give me 0 again. So I'm going to do a times 0, which is going to... So I need a point besides an x-intercept. So what is another good point we have besides an x-intercept? Does anybody see any good points? Yeah, 2 -3 works. So let's plug in to -3. So instead of y, we'll replace with -3. And x will now become 2. So we'll have a times 2, which is 2a. 2 plus 2 would end up being 4, all squared. 4 minus 1 would be, 2 minus 3 would be -1 squared. And now it's just solving for that a value. So we know 4 squared would be 16. What's -1 squared going to become? 1. So that's 16 times 2, 32a. And we know a would end up being equivalent to what value? What would a end up being? -3/32. 32, which, let's check back in with that idea, right? A was negative when we solved. Cool. Good. We needed that. So, writing our final equation, A is negative 3 over 32. X times x plus 2 all squared and x minus 3 all squared.
That's a reference.
What other questions do you guys have here? Alright, so other ways you could check to make sure you got this right would just be to plug in values and make sure you kind of get the right output. You know, like you could plug in 2, your output should be negative 3, things like that. Alright, let's do the opposite direction now, which is graphing our polynomials. So, kind of start off with identifying from your equation key points, right? What are some key points? Always our intercepts. So finding your y-intercept, how can I always find a y-intercept? How can I always find a y-intercept?
Plugging 0 for x.
Great job. So I know that would mean just make x equal to 0 and see what the output is. And then I want to find my x-intercepts and their multiplicity. So how can I find x-intercepts?
Plug in 0 for y.
Yep, y becomes 0, and then I'd probably have to do what? I'll probably have to see if I can. Yes, and what was my skills with solving for x? Probably always checking to see if we can do what first. Yes, good. So from there, if you want to plot another key point or two, be my guest. And then always use your end behavior to finish your sketch. So I want to make this clear to everybody. With this graphing polynomials, every other time throughout the year, you had to have like very nice specific points. Here, your very nice specific points are your intercepts and your end behavior. From there, my graphs are not going to be perfect and beautiful. Therefore, I don't expect yours to be perfect and beautiful. But to get yours to be as nice as you can keep plotting more points. For me, it's more important to see your intercepts and end behavior. So, let's do it and see. Why don't you guys take a moment, jot down our given polynomial, and looking at that function, what are some characteristics that you know that your graph will have?
I'm so excited. Why are you looking at like that? Because I'm solving it.
Alright, so we have negative x cubed plus 2x squared plus 4x minus 8. What are some present features of your graph you're seeing from this equation? Ooh, we got a degree of 3. What else do you guys see? It's a negative coefficient. So if I got this going on, a negative coefficient, degree of 3, that will tell me a lot about what on my graph.
What the line looks like.
Kind of what the ends
End
look like.
behavior.
End behavior, good. The end behavior. So what would my end behavior be if I have a negative coefficient and a degree of 3? What will that look like?
You probably start at the first positive.
Yeah, would you be doing same direction or opposite directions?
Opposite.
Are we gonna be going up or down first?
Up.
So we'll do like from on the left side, would it be going up or down? Up and then down. Think about making that like negative slope. So, cool, that's a good thing I need to know my end behavior. What else do I see?
Y-intercept of -8.
Great, how'd you know that's the y-intercept?
Because if we put 0 for x, then we get -8.
Awesome. So guess what we got, everybody? We got our first good point of this y-intercept of -8. Okay, look at that on our graph. What else can we find, or should we be looking for? What else should we be looking for? What do you know, Laura? Yeah, we know we gotta find our x-intercepts next. We found our y, now let's find the x-intercepts. So to find my x-intercept, you guys already told me earlier y becomes 0. And what else should I do with my function? Let's find those x-intercepts. What do we think?
Oh, factor it.
Oh, factor it, yes. So this would be minus x squared, and then you'd have x minus 2. And then I'd factor out 4 to be x minus 2. So let's check. Is this factorable? By grouping? Yep, those x minus 2's match up. So I know one factor is x minus 2, and my other is negative x squared plus 4. Now let's check in with negative x squared plus 4. Can I keep factoring that? Yes. So it kind of looks like the difference of squares, but not totally, right? I could make it look like the difference of squares if I factor out what? A negative, yeah. So if you factor out a negative, I'd end up with x squared minus 4, and then x minus 2. And then now I know I can keep factoring x squared minus 4 to become what?
X minus 2.
Good job. So lots of things to check in with that you guys were noticing, right? We noticed we had this negative coefficient for my a value of -1. So I can see that -1a value all the way out here when I'm in that factored form. So I'm factored. Now how do I find my x-intercepts? We set each factor equal to
0.
Yes, so I have x minus 2 equaling 0, x plus 2 equaling 0. So if I have x minus 2 equals 0, I know x will equal just 2. And if I have x plus 2 equals 0, I know x will equal -2. But look what else, what do we have? I have another x minus 2 factor. So what does that mean is going to happen? I'm going to have a bounce where?
At -2.
At not +2, right? Because basically what happened, I have this twice, which means I'm going to bounce because this has a what? That word that starts with an M?
Multiplicity.
Good job. This has a multiplicity of how many?
2.
Good job. So let's start to kind of put in a skeleton, if you will. So we know we're going to cross our x-axis at a +2 and a -2. And I know at -2, what does it look like through, or I should just gave it away kind of. At -2, you just cut right through, right? Because there's no multiplicity. And I know at +2 there's a bounce. So my bounce is going to be either looking like this or like this. But I don't know right now until I start to put in more of my features what's another feature I do kind of know?
And behavior.
The end behavior. So I know my end on the left is going to be going up. And I know my end on the right is going to be going down. So let's look over here at -2. I can kind of just connect these to kind of finish that out over here. What about a +2? What do you think the bounce should be doing? A down bounce or an up bounce?
Down bounce.
Down bounce to help me connect back here.
I'm so excited.
So
I don't know.
here, get rid of that rough little sketch. Now, like I said earlier, does this have to be perfect? No. These are the perfect things I should see. Intercepts, multiplicities, and behavior. And then from there, if you want to find 1 or 2 more good points, let's do that. So let's maybe plug in -1, and let's plug in +1, and see what those outputs would be. So let's take a minute and do that to kind of finish our sketch a little bit. All right, so if you plugged in -1, what was the output? Anyone plugging in -1? Anybody plugging in -1? What was the output? Did you all just sit and stare for a minute?
-10.
I think it's -9.
Oh, okay.
What about, so think about
That's so
-1,
close.
-9. What about if you plugged in 1, what was the output? -3.
Good job, Sophia.
There we go, 1, 2, 3. Okay, that was like tracking along, right? So now let's just connect our graph right through. So what do I know? If my degree was 3, I could have like 2 turning points. Do I have 2 turning points? Yep. And I see I have my 3 roots. I got that good end behavior. And if you're doing this for practice, like on your Delta Math, you know, you can always like try and kind of figure out all those points, and then you can kind of check with a graphing calculator, only as a way to like check your work, not as like a way to do the problem. Got it? What other questions do you guys have? All right. This is our last question doing together. So why don't you guys take a minute, jot it down, see what characteristics you're noticing. Alright, so looking here, we have x to the 4th minus 4x squared plus 3. What was something you guys are noticing about this graph? What did you see, Laura?
It's positive.
Yeah, you have a positive coefficient, and your degree is even. So that's helping us know what about the graph. Good job. Both my ends are going to go up. So my end behavior is going to be like up and up. That's a good start. What else are you thinking about? What do you see, Ruby? The degree is 4. So what do I know about that if my degree is 4? I could have like 3 turning points, right? Maybe I cross my x-axis how many times? Or touch your x-axis how many times? 4 times, right? What else could I be seeing and noticing? The y-intercept is 3. So my y-intercept is 3. Let's put that on our graph. That's a good solid point. What are some other good solid points I want to be looking for? some good other solid points I'm looking for. X-intercept. So to find an x-intercept, y becomes 0. And how I don't have 4 terms, so I can't group here. But I do know that I have like that x to the 4th and x squared, meaning my first term is squared of my middle. So I can factor that just like I would a regular quadratic, but instead of just x, I use x squared. So what would those factors be? What do you think, Morgan?
So you get what, -1, and then
Oh, before that step. What did you do before that step?
I got like x squared minus 1, and then x squared minus 3.
Great. And then what did you notice after that, Morgan?
Then I got I did x minus 1,
Uh-huh.
x plus 1,
Yeah.
and then I did x squared equals 3.
Okay, yeah, because you're starting to think about solving next, right?
Yeah.
Great, so let's pause before we get there. So we haven't factored all the way, right? We noticed that x squared minus 1 we keep factoring with those difference of squares. So now we want to solve. So to solve, what am I going to do?
Set it equal to 0.
Set them equal to 0. So I have x minus 1 equals 0, I have x plus 1 equals 0, and I have x squared minus 3 equals 0. Alright, so if I have x minus 1 equals 0, what will x be? X will be equal to?
1.
1. What about next up, x will be equal to?
-1.
-1. Boom, boom. I'm halfway there, right? 2 of my 4. Now where are my other 2 going to come from? This is a quadratic, right? Degree of 2. So this is where they're coming from. 5x squared minus 3 equals 0. What would x be equal to?
Plus or minus, you add 3.
Great job. I add the 3 over, take the square root. When I take the square root, I have plus or minus. So let's plot those points on our graph. We got 1, we got -1. I'm doing this without a calculator, so if I wanted to use a calculator, I could really approximate the square root of 3, but I know it's going to be equal to probably close to what number? Probably close to, but not quite yet, 2, right? Because what's the square root of 4? 2. 2. So it's not quite 2, but it's going to be close to 2. So it's going to be really close to positive and -2. So, right? Somewhere close, right around here. And what else can I kind of add into my graph that we knew from the beginning?
Y-intercept.
Yep, we already got that. You can also add in the and behavior. So do any of these points have multiplicity? Do these have multiplicity here? No, so I know I'm going to be like, whoop, whoop, right on through, right? And because these are so close, they're going to have to turn around real quick to get right back up. So I know I'm going to probably turn around right here, turn around right here. I'm going to whoop, and I'm going to whoop to connect it. So it looks kind of like this little W, right? And is my graph perfect? No. But I got some good, perfect points that I should have, which are my intercepts, my end behavior, things of that nature. And if you are wanting to be more of an artist than me, remember you can plug in some other good points to kind of find them along the way. What else do you guys have questions on from today? All right, you guys have a little bit over 20 minutes left in class for time to work on Delta Math. So go ahead, everybody, get that computer out. Shout out to you guys for all getting in that part 1 of your homework done. So that part 2 is due on the 30th. So go ahead. If you have not started it, this is your time to start it now.